Hello, welcome to Python Foundations Session 5. Today we will be going over the Pandas library. If you haven't done so already, feel free to watch the first 4 videos in this Python Foundations series. You should be able to find them in the YouTube playlist. Also, all videos are linked at the top of their respective notebooks on the Python Foundations website. Okay, without further ado, today we will jump into the Pandas package. Packages are collections of related functions. These are the things that we import. Pandas is a 2-dimensional data structure like a spreadsheet in Excel. In fact, we will be importing our first data set and viewing it with pandas. Pandas is actually short for panel data. Pandas and scikit-learn load datasets. We begin by loading the pandas package. Packages are collections of functions that share a common utility. We've seen import before. Let's use it to import pandas and all the richness that pandas has to offer. We'll also use a very useful feature of the scikit-learn toolkit, the load datasets module. We will do some very rudimentary tasks with this dataset just to demonstrate the utility of load datasets. Then we will switch over to a more relevant dataset for our learning purposes. Right, so I'm importing pandas here. We're going to redo this, by the way, later on in the notebook because we frequently use an alias with the pandas library, but for now we'll just use this import statement as is. And then from the sklearn package, we are going to import from the datasets module a specific function called loadWine. Note the syntax here. Let's give this a run. We import a function loadWine that loads a simple dataset we can play with called the wine recognition data set, and it dates back from the 1980s. I have a link here for you to read more about. Now, within the object that is returned by the loadWine function, we have an attribute called DESCR that returns a description of how this data set was created, as well as some metadata about the features in the data set. We won't go into too great of detail here, but I just thought this was an interesting aspect of the load dataset module in sklearn. So I may have mentioned this before, but scikit-learn is the primordial machine learning library in Python. And one major reason is that they go to great lengths to make it so accessible, like this load dataset library, right? We have all of this interesting wine data to learn from, and it's well organized, and we have metadata about it, and we can read about all of this, the way the data was captured and so forth. So pretty cool. All right. The main object, this is just a sneak peek rather of what's to come. The main object that we work with within the pandas ecosystem is called a data frame. And we access data frame from the core pandas package, right? So we're not going into any submodules here. We're just in the core pandas package. We're accessing it by calling uppercase D eta, uppercase F frame. And this creates a pandas data frame. More on that later. Okay, I mentioned that we were going to do this. At the top of this notebook, I imported pandas, right? But we'll frequently do this with some of the common libraries that we use in the scientific computing stack in Python, and that is we will give them an alias. And the way we do that is with this reserved word as. So instead of using the pandas namespace to grab all of the different package or modules rather and functions within pandas, I'm going to give that package the alias PD. And we will almost always do this with the pandas library. If you look at anybody else's code, they're going to import pandas as PD. They're going to use that shorthand for ease of use. And so now the pandas.dataframe method that we used earlier becomes pd.dataframe, right? So we're using PD instead of pandas. All right, so this builds right here an empty data frame object. Let's open the wine data set and then feed it into that data frame function and see what we get. So here I'm calling pandas data frame again, but I'm passing the data from that load wine data set. And I'm also passing the names of those column headers and passing it to the parameter columns. We'll see more of this later on in the notebook, but for right now, I just want to give you a quick and dirty view of how we can easily load data into the Pandas data frame. All right, from Excel and CSV, we will now be reading the data from this link. So we can visit this link real quick. Right, so I've shift tabbed over to where that link led me. This is a fake data set that I created for this module. You can see that this is a series of comma separated values, otherwise known as a CSV file. So we can read CSV files directly into Pandas and load it as a Pandas data frame by calling this method read CSV. Read CSV will then take either a directory path to your CSV file or a URL. Pretty handy. We can do this in a similar thread with Excel files using a method called read_Excel. And here again, I am passing a URL where I have stored the same data set, but as an Excel file rather than a CSV file. Nice, so we have some pretty rigorous and useful options for how we import data into Pandas. Okay, I want to break this down into a simpler demonstration before we move forward. So instead of reading in a complete data set, how do we build a data set from scratch? How do we leverage some of the simple data structures we've learned earlier in the course to fold them into a data frame object? Let's start with perhaps the simplest example, a list of lists. So note here, I've got a list of lists. The outer list contains 4 elements rather. And each of those elements is a list itself that, again, contains 3 elements. All right, so let's load this into data frame. Note how the outer instances, that is, the list that contains the sublists, is converted into instances or rows. And then the elements on the inner list are converted into columns. Right, so we have 3 columns, 4 rows. In data science nomenclature, you heard me say that the rows might be instances. We would call the columns features. And so you'll hear me refer to one or the other sometimes. Now, that's all well and good. What if we have specific index labels we'd like to use, perhaps specific column headers we'd like to use? We can pass those directly into the call to Pandas data frame using the parameter fields index for indices and columns for, you guessed it, column headers. So I want to give my rows A, B, C, and D as their indices, and my column headers X, Y, and Z as their label names. And we see how the Pandas data frame has been updated with the corresponding labels. So that's it with lists of lists. We can also use dictionaries to build Pandas data frames. Note here that I'm using my keys that will become column headers. And then my values are lists where every element of the list is a row. Right, so under the header A, I have apple and airplane, and under the header B, I have banana and bubbles. Side note here, we can take a Pandas data frame and convert it back into a dictionary. This is super useful as we're looking to perhaps create APIs with some Python server that we've created, right? Because the default object to pass around in an API is a JSON structure. What do we notice about this dictionary? It is essentially a JSON structure, right? So this is the common way we might communicate with other programs that want to use the output of some Python function we've written, right? So this toDict could be really useful for you in the future. A very nice feature. Exercise 1, create a data frame. Create a dictionary with the following keys: movies, songs, books, and each key lists your top 5 favorites in the corresponding category. Then use pd.dataframe to turn this into a dictionary. If this is your first time watching a video, feel free to pause the video and work on the exercise yourself. I will go ahead and solve it live. All right, so let's see. Dictionary. So how do I do that? I'm going to use curly brackets. I'm going to call this my dict. And we're going to have the keys movies. There'll be something here. And then songs. Notice how my auto indentation aligns with the beginning of the latter key. Pretty nifty feature here. This is also good PEP8 style. And, oh, I don't want a string, I want a list. So here we'll go with a list. Favorite movies, let's do Dune, maybe Matrix, maybe Return of the King, maybe What Dreams May Come, Rippeth, Robin Williams. And then 1, 2, 3, 4, Soul. All right, we got to throw a Pixar movie in there. Actually, let's get rid of Matrix and let's do Princess Mononoke. Don't know if I spelled that right. All right, songs. I always go for Claire de Lune. I don't know why. Not sure if it's my favorite or not, but it's always the first song that comes to mind. 5 of these, huh? Let's just go with some. Let's just go with some Beatles song. I don't know what's the one. The Beatles song about the bird. You know what I'm talking about. The Coldplay song about the scientist. That's a good one. Ricky Martin comes to mind. I don't want to put Ricky Martin in here. How about, Father and Son? That's a good one from Cat Stevens. While we're on the 70s bent, let's do, what's a good Peter, Paul, and Mary? The In the Wind song from Peter, Paul, and Mary. There we go. We're really just limping along here. Books. Well, I have better luck with books. Can we recycle some stuff? Let's do Return of the King. This is taking entirely too long. I'm sorry. Harry Potter 1, HP 2, HP 3, and HP 4. Wow, that was exhausting. We've got it now, though. My dict is complete. Now, before I pump this into a data frame, I want to see if my code so far computes. Let's look. It computes, right? Our dictionary, we're not throwing any errors. Okay, so now that I know that, I'm going to pass this into a data frame. pd.data frame should be no problem. Nice, there we go. Harry Potter doesn't make my top favorite book list, by the way. Just gonna throw that out there. All right, pandas.series. So this quick side note, we're not gonna spend too much time on this, but I wanna say pandas series objects will percolate in our experience here and there. However, they are not so important as for us to wish to spend dedicated time on them. For now, know that they are a lower level data collection in the pandas framework. You can think of them as an individual column or an individual row in the pandas data frame. For more practice with these, you can refer to this documentation. All right, moving on. Viewing pandas data frames. So we'll spend some time on viewing pandas data frames, and then we will move over to manipulating data within pandas. And that's going to be the big heavy haul for today. All right, viewing pandas data frames. You're going to use this all the time. df.head will return the first 5 rows of your data frame. It takes a parameter. That parameter will be the number of rows you want to view. So if I change this to 10, I'm going to see the top 10 rows. If I change it to 2, it'll show me the top 2 rows, etc. df.tail, same deal. By default, shows the last 5 rows, and you can pass the first positional parameter to change that default number of rows. df.shape will show us the number of elements along both rows and columns. So df.shape in this case, I don't know if I mentioned this already, but that last data frame that we piped in is the IMDb data set. So that's what I have saved under the variable name df right now. So that IMDb data set has 85,855 instances, rows, aka in this data set, that means movies. And then it has 22 columns, features, in this case, metadata associated with the given movie. All right, so 22 columns, 85,000 rows. Another useful attribute is df.columns. Use this all the time. You're not going to remember every column, in particular, you're not going to remember how every column header is spelled. And you'll note this as you begin working with other people's data sets. Usually their columns have typos in them. We're looking at some, back office data set that hasn't been consumer facing yet. So there's going to be tons of typos in there. Really useful to call df.columns. df.index, another useful attribute, shows us the indice labels on the rows, right? And we'll see here that there's An interesting data type that's returned, similar to the range function, right? It shows us the start, stop, and step. Again, just to save on memory, so we're not passing an 85,000 element long list to the output of this cell right here. df.datatypes, another super useful attribute, will show us the data type that exists in each column. Right, so we have some objects that most of the time will be strings, some floats, and that's it for this data set. Well, integers and floats for this data set. df.describe, note this is a method, not an attribute because of the parentheses. If you have a mixture of categorical data and numerical data, df.describe will preferentially focus on the numerical data and give us essentially the information you need to make a box plot. So, Q1, Q2, Q3, min and max, mean, standard deviation, count. If you only have categorical data, however, it will return stats for the categorical data, things like frequency, top occurring string value. So a different set of data. If you have a mixed data frame, such as we do now, you will have to filter your data frame before passing it to describe, right? And so we're going to get into filtration here in a moment when we talk about manipulating data with pandas. Before we do that, though, a little exercise. Exercise 2, viewing data frames. Using the data frame you made in exercise 1, return the following attributes: the data type stored in each column, the column names, the indices, and the shape. So we're just accessing these attributes that we just learned about. So I'm going to go back to exercise 1 because I don't think I actually named my data frame. So you may have to do the same thing. And I'm just going to call it DFF. You'll also see people do that in their code, appending Fs to their DF name. I don't know how I feel about that. It's real sloppy. You do want to give things meaningful names, but people recognize that DF is going to mean data frame in most cases. All right, so we have DFF, and we want to return the data type. So that's going to be plural, right? D types. And we'll go ahead and pass this into print so that we can string these along in the same cell. Let's print now column names. So that's going to be df.columns. And then we want dff index. I believe it's index. It might be indices. Let's see. Nope, index works. And then the shape. Right, the shape is 5.3 because we had five examples for each of movie, book, and song. Cool. Manipulating data with pandas. So this is the next major section of this notebook. If you need to get up, take a break, feel free, pause the video. All right, here we'll cover some key features of manipulating data with pandas. The paradigm I want to introduce here is select, filter, operate, right? So those are the 3 things that we are going to do with our data frame, and we're going to start with select. Selection means accessing columns by accessing columns, right? So select is going to be accessing columns, filter is going to be selecting rows, and then operation is going to be doing some kind of aggregation on that data to garner some kind of insight, right? So this all makes sense as we go forward, but starting with selection. I can select a column the same way we selected data with lists and dictionaries, and that is square brackets. The simplest example I can give is passing in the column name. So if I wanted to look at the duration of all my movies, I simply use the square bracket, the string value duration, which is the column name, and that will return every row in the column duration. Mathematical operations on columns happen element-wise. So if I wanted to convert duration, which is in minutes, to hours, I would just pass divide by 60. Look at that arithmetic. Super simple. Columns can be created or overwritten with the assignment operator, the single equal sign that is. Let's create a column with duration in hours. So here, I'm making a new column. Notice I'm doing so the same way we would make a new key in a dictionary, just using the square brackets, right? And I pass into those square brackets the string name I want to give for that column. I use the assignment operator, otherwise known as the equal sign, and I pass in that element-wise calculation we did earlier. And now if we use df.head, we'll see that at the very end of our data frame, we have this new column, duration, hours. Magnificent. All right. This next topic, lock and iLock, can get a little confusing to people first encountering pandas, but it's really important that we get the knack for this. And you'll see why in a moment. Pandas provides a powerful way to work with both rows and columns together. optionally using their label indices or numeric indices. Let's start with dot lock. Dot lock is the former approach with label indices. Purely label location-based indexer for selection by label, but may also be used with a Boolean array. We'll see more of that, especially in the lab that corresponds to this session. Important, if you use slicing and lock, it will return the end index as well. So this is, as far as I know, at least in this course, the only time where we will see inclusivity on the upper bound, right? So we'll have an example of this momentarily. .iloc, purely integer location-based indexing for selection by position, but may also be used with a Boolean array. All right, let's go for this. Starting with df.lock. Note here, I'm passing along df.columns indexed at 1. I'm just reminding myself of what indeed that column is, its title. All right. So now on to df.lock. It turns out, okay, this is where it can get confusing. And we'll have some examples down below where the indices are non-numerical. But in the IMDb dataset, because we didn't specify index labels, by default, our index labels are numerical. Okay, so the only reason I'm able to pass numbers to .lock right here is because it just so happens that our rows don't have string values. They're numbers, okay? And here I'm passing a slice, right? So we'll remember with our earlier sessions, before the colon is the start, between the two colons is the stop, and after the second colon is the step size. So I'm going to start, and because I've omitted the start, the default there is 0. So I'm starting at 0, going up to 5, and my step size is 2. Hence, when we look at the output of this cell, we see rows 0, 2, and 4. Okay? And now, because I've used .lock, I'm going to pass in after a comma the columns I want to select. So here I've got df.columns indexed at 1, which returns title, passed in as a list. Okay? So if I wanted to do multiple columns, again, I could use slicing. And because I'm slicing, I'm no longer needing to put this into a list. And there we go. I've got both IMDb title ID and title, right? And I can, just to show what I'm doing here, let's do the slicing up here, right? My slicing is returning a list of column names. So I'm just putting df.columns sliced at 3 into .lock, right? So we're passing this into the .lock. Nice. Let's take the simplest possible example here, right? Let's narrow this down. Right, so in this simple example, what I've done is I passed in the column I'm wanting to grab, the row I'm wanting to grab, right? Row 0, and then the column I'm wanting to grab, title. Cool. Now on to .iloc. .iloc is purely index-based, okay? So in this case, I'm always going to pass numbers. I'm not going to pass string values. So in this case, and again, we'll have to remember our slicing, I'm starting 5 away from the back row. And I'm doing that because of the negative sign here, right? This -5 as the start means I'm 5 away from the very last row. And then having a blank end point means I'm going to go all the way to the end of the data frame. Comma ends the portion on rows. And now we're going to start with the portion on columns. And I'm passing a list of column values I want to grab, but not the labels, rather the index associated with those labels. Right? So if I wanted to look at what labels these are, I could do df.columns. At 3, we have 0, 1, 2, 3, year. And at 5, we have genre. Okay, so because I've passed 3 and 5 in .iloc, we see the columns year and the columns genre. Nice. Okay. Now, if we weren't to use .lock or .iloc, we still have the ability to access specific rows and columns. And we can string this together however we like. So I can first access rows and then the column I want. I can also access the column I want and then the rows. All right, so this returns the same thing. Okay, and you might be asking, Wesley, well, if we can do this without .lock and .ilock, why are you showing us .lock and .ilock? I'm glad you asked. Let's take an example. So in order to show this example, I'm going to build a simpler data frame. So IMDb dataset, put that on the shelf for now. We're going to look at this new data frame called MyDF. Column headers are alpha, beta, gamma. Rows are A, B, C, and D. All right. So let's say I wanted to change a value in my data frame. I'm going to do it with either .lock or .ilock. So I'm going to do MyDF.lock. I'm going to grab the A row and the alpha column, and I'm going to update that to myChange. And now if we look at MyDF, we'll see the change has taken place. Now, if I do the following in this cell, right? So no longer am I using .lock, no longer am I using .ilock, but I'm trying to set a new value to the original data frame, I'm going to get a warning, right? And this warning will be dependent on which version of Pandas you're running. But what it's telling you is that, hey, user, you're trying to set a new value to a view of a data frame. In other words, a copy, or rather a copy of a data frame instead of a view. So when you're using .lock and .ilock, what you are returning is a view, right? You're viewing the original object. In contrast, when you access a data frame without .lock and .ilock, you are looking at a copy of a data frame. So unbeknownst to you, if you try to set a new value to a copy of that data frame, more often than not, you are not actually going to change the original object. So there are some caveats to this, but without going into the going too far down that train, I just want to say if your intention is to change the value of the original data frame, always just default to using .lock and .ilock, and then you can avoid accidentally not changing your original data frame. Cool. And that's it for that. Moving on to selection, or excuse me, before we move on to filtration, let's take an exercise with selection. Select the first 10 rows of the country, genre, and year columns using lock. Repeat the same exercise using ilock. All right, so again, we're going to use the IMDb data frame, which is stored under the namespace df. And let's grab the first 10 rows. .ilock and first we're going to do it with .lock. All right, first 10 rows. Remember, with .lock, the upper bound is inclusive. So do I want to go to index 10? No, I want to go to index 9 because 0 through 9 will give me the first 10 rows. And then we want the country, genre, and year columns. Wunderbar. All right. Now, to do this with .ilock, I need to look up what index country, genre, and year are stored under. So I'm going to df.ilock. And then this time we'll include 10 in the upper bound because it's exclusive. And now I'm looking for country, genre, and year. So let's count through here. 0, 1, 2, 3, there's year, add it. 4, 5, there's genre, add it. 6, 7, there's country, add it. Nice. And so we have the same data returned. Note that because I passed country, genre, and year in this order, the orders are different. Could maybe switch these. Country, year, and then 5 can come before 3. All right, so now we have the same exact thing returned between the two. All right, so two different ways to access the content in this data frame, returning a view rather than a copy. Alrighty, now moving on to filtering. Filtering down your selected columns will be bigly useful in your data quests, right? We can compare this to all the different leak code problems on SQL queries. Similar content here. All right, starting with an example with strings. One of the first tools we'll use to filter our data set is the .str.contains method. Let's take an example. Remember, if we don't remember our column names, we have the nifty df.columns to remind us. And I'm going to do df description.str.contains, pass in the string value a.i. setting this parameter flag na to false. what this is going to do is, well, so something that's happening here is the period is being interpreted through regular expressions. I don't want to go too far into the rabbit hole of regular expressions here, but what this means is the period is going to be a wildcard. So unbeknownst to us, we may be trying to access a title that has a.i. in it. In other words, artificial intelligence, but the period is a wildcard. Now, as for the parameter flag NA, setting this to false, what this is going to do is if there is a description missing and we're unable to do the conditional comparison, then just set the Boolean outcome to false. All right. Now, if we look at, check this out. So on row 1, it says we have the condition is met. So let's take a look at that. We'll do df dot lock 1 description. The true story of notorious Australian outlaw Ned Kelly. Notice that here we have A, L, I, A, right? So the period is a wild card. So let's pretend that we didn't know how to escape using the period as a wild card. Another way we could go about performing our query is expand out AI, right? Expand it out to artificial intelligence. So here I'm doing the same thing again. I've written out artificial intelligence. And this returns again a series of Booleans. What we can do now with the series of Booleans is we can use them in the selection criteria on the data frame. And we can do that with the raw data frame in square brackets. We can do it with the data frame and .lock. We can do it with the data frame and .ilock. We have a host of options. Let's imagine for right now that I'm okay with returning a copy of the data frame and not a view. So I can omit .lock or .ilock. That series of Booleans is now going to be interpreted by the selection as, hey, only give me the rows where this evaluates to true, right? And so this is how we do our filtration in Pandas. Super useful. And it looks like our query is returning relevant information. The movie Stealth is familiar to me. That's an AI movie. Same with Transcendence. Some of these other ones I am not so familiar with. All right, so that's it for string.contains. Let's take a simpler even example. If we know the exact criteria we're searching for, and we don't have to do a sort of a contains match, we can just use the double equal sign. So say we wanted to look at the movie Fight Club. All we do is we query the title column for any row that contains the string Fight Club. Check this out. If I pass this by itself again, we're returning a series of Booleans. So what I want to stress is that as you're going about performing these filtrations, get used to thinking along the mindset of, I need to return a series of Booleans. And if I can return a series of Booleans, I can then pass that in as my selection criteria on the original data frame. So once I have this, I simply surround it with square brackets and feed that into df, right? And so there's the movie Fight Club. Awesome. We can also filter by numerical value. So imagine we only wanted to look at movies with a certain number of votes. We say, hey, I only want to look at movies with 1,000 votes. And then our data frame is down filtered. Something else that can be useful to us is at the bottom of the cell, we are shown the number of rows that are returned, right? So out of, I think there was like 58,000 movies, 29,000 of them have more than 1,000 votes. Exercise 4, filtering. Let's filter DF for all the movies that are longer than 2 hours. And then let's filter DF for all movies where day is in the title. So we'll start with the first one first. No, I'm going to make my series of Booleans before I pass it into DF. So here we want to select duration and longer than 120 minutes, right? Looks like that's working. I'm going to pass it into DF now. Wonderful. 11,000 movies are longer than 2 hours. Now let's do title.string.contains day. And we can set NA to false again. Forget if the default is false or not. Let me check. Remember, we always have our tooltip to remind us if we can get it working. Sometimes the tooltip doesn't come up if you have down selected your original object. Let me see if I can do it with sad day. So we have no tooltip for string.contains, but luckily we have Wesley here to tell us, go ahead and set this parameter NA to false. And now we can pass this into df. Awesome. So like we got Saturday night, the road to yesterday, the devil's holiday, etc. Awesome. And that's it for exercise 4. Now, that last step, operation. The real power of Pandas comes in its tools for grouping and aggregating data. Here, we'll look at value counts and the basics of group by operations. All right, so here's an example of a select, filter, and operate paradigm. Here's my filtration step, right? I'm filtering for only movies that were made in the US, and then I'm selecting the duration column, and then I'm operating on it with the describe method. Remember, we saw describe earlier. It returns some statistical data about the column in question. Cool. One little trick that I want to share with you is a method of inverting every Boolean in a series, and that is using the tilde operator. Super useful. So say you wanted to compare US movies with non-US movies, we write the same exact query, except that we put a tilde in front of our condition. And now the selection is inverted. Right? So we have 28,000 American movies, 57,000 non-American movies. The average movie length in America is 93 minutes and 103 minutes for non-American movies. Interesting. In preparation for grouping the data, I want to show us a new method here. Let's bin the instances by their duration. Note we could have chosen any numerical column for binning. For that, we'll use pandas.cut. I have a link to the documentation here. It is used to bin values into discrete intervals. This is like a middle step of creating a histogram, where for each bin along the range of values you're looking at, you count the number of occurrences in that bin. In our example, we'll use 10 bins and let Pandas decide how to evenly divide the range into the bins. Let's see it in action. Right, so the histogram comparison here that I'm making is simply that in a histogram, you similarly create equidistant bins, right, depending on what your range is. And in a histogram, you're depositing counts. In this case, we're not depositing a count. We're simply assigning each instance, that is each row, to a certain bin, whichever one it happens to fall in. And pd.cut will determine for us automagically what those bin ranges should be such that they are evenly divided along the range. Okay, let's take an example. So I'm going to call pd.cut. I'm going to select the duration column, and I'm going to say I want 10 bins. And then I'm going to set the output of that to a new column in the data frame called duration_group. All right, that's a lot of stuff. Let's just break this down. So first, I'm going to show how I'm using pd.cut. Right, so now pd.cut is returning for every instance which bin it falls into. Note the use of a parentheses on the left to notify us that that's inclusive, and a square bracket on the right to show us that that's exclusive. All right, so all I'm doing now in this cell is I'm setting that equal to a new column duration group. And then we can call upon df.head, scroll all the way to the right, and we see that associated with every instance now is a specific group that is a range of movie lengths that movie falls into. We can call df.datatypes and see that that last column is a different data type we haven't seen before, a categorical data type. Pandas includes an array of useful functionality for manipulating and analyzing tabular data. We'll take a look at 2 of these here. The pandas.valueCounts returns statistics on the unique values within each column. We can use it, for example, to break down the movies by their duration group that we just created. So let's just take that example. I'm calling pandas.valueCounts, passing in this, get this, it's a categorical variable, object data type, right? Discrete values, all these are using interchangeably. And what this is doing is it's counting the occurrence, back to the histogram analogy, it's counting the occurrence of an observation in each of these bins. So let's analyze this. Between 40 minutes and 117 minutes, we have 72,000 movies, right? So the large most of our data occurs in this range, right? 72,000 out of approximately 80,000 or 88,000 data points occurs in that range. Next, we have between 117 and 194. So next bin up, we have 13,000 occurrences or observations in that range, 228 observations between 194 and 271 minutes, and etc. So big peak, long tail in this data set. What happens if we try this on a continuous value variable? So, right, I made the point that was categorical or discrete values. If we try to do value counts on a continuous variable, we don't get an error, but we're going to get a ton of rows returned, right? There's 266 unique values for duration in this data set. So this is kind of hard to interpret. So typically you want to use value counts for categorical or discrete data. Exercise 5, playing with value counts, unique and n-unique. We can do a little data exploration with this by seeing how common different values are. Play around with these pandas methods, value counts, unique and n-unique. Also be sure to use selection, filtration, and you are already using operation with the above mentioned pandas methods, right? So value counts, unique and n-unique are going to be our operation that we string at the end. All right. Do so with 3 different columns in the data frame. So I'm probably just going to do 1 for time's sake. Let's think about what we might want to see. What if we want to look at the number of unique movies by country, but with more than 1,000 votes, right? Let's think of that. So let's do df. We want the length to be, or no, the number of votes to be greater than 1,000. Okay, so we're only going to look at, I guess, popular movies. We've now filtered our data frame. So there's the filtration step. We want to select now. So what do we want to select? We want to select country. So there I've selected country. And now we want to do some kind of operation, right? And in this case, I want to look at how many movies we have for each country. So the way I'm going to do that is dot value counts. Amazing. Right, so we have 11,000 US movies, followed by India with about 2,000 and UK with about 1,300, right? So kind of interesting. What if we removed this filtration step? Let's just say larger than 1 vote or 0 votes even. All right, the rank order is the same. US, India, UK, Japan. Actually, was Japan 4th? Yes, US, India, UK. France, Japan. Oh. So Japan, maybe sounds like it's like pumping out a lot of obscure anime movies, maybe, or any other kind of movie, but they aren't getting a lot of votes. When we screen for votes, France jumps ahead of Japan by a very slight margin. Cool. All right. Did not realize that that would be a difference in rank order there. Okay, so that is a major paradigm with pandas, right? Select, filter, and operate. That's going to give you a ton of horsepower when you go into doing some exploratory data analysis. But there's one thing we haven't mentioned yet. I mean, this has an analogy or analog, I think maybe is the word I'm looking for, with SQL, right? SQL's got group by as well. Very, very powerful data analysis technique. So let's dive in. Group by. One of the killer features of the pandas data frame is the ability to do group by operations. You can visualize the group by like this. And I borrowed this from Jake Vander Plas's Python Data Science Handbook. So we have our input data here on the left. X is what kind of data? Categorical, right? It's got A, B, and C. Y is numerical or continuous. All right. We're going to split along the categorical column. Now we have 3 different data frames. One containing all A values for the X column, one containing all B values for the X column, and one containing all C values for the X column. We then apply some kind of operation, some kind of aggregation, right? So this could be, I think in this case, it looks like we're taking the mean or the average, right? The average of 2 and 4 is 3, 0 and 5 is 2.5, 5 and 10 is 7.5. So we do some kind of aggregation. It could be anything we like, right? And then we automatically combine the results to create a single output data frame. So whenever we group by something, what we need to do is we need to specify which column we want to perform the grouping on. In this case, this user that created this diagram specified column X. We also need to specify the aggregation we want to perform and what column we want to do that aggregation on. So in this case, the user said, I want to take the mean of column Y, and then the group by automatically does the combination for us. We don't have to specify that. That is a lot. Pause and rewind and let that stick. Folks tend to, this is a big one to chew, right? So be gentle with yourself. We'll get some practice. Summary statistics with group by. Some of the common ones we might use are value counts, count, and describe. I like describe a lot, especially for rudimentary exploratory data analysis. I'll call that EDA from now on in this video. For rudimentary EDA, describe is really useful because it gives you a whole host of summary stats without having to like do each one individually. Let's break this in smaller steps. Recall our duration group column, right? It's a categorical column now. We made it. So to continue with that example, why not use it? We can do PD dot value counts and then pass in duration group. That's one way to perform this summary of that column, but we can also do this with group by. So let's look at that. Group by allows us to look at the number of values for each column and each value. We have a link to the documentation here, but basically group by allows us to create groups of records based on their values. Let's count how many records or rows in our data set fall into each bin of our duration data. So here I'm going to call df.groupby. Note that groupby is a method within the object. It's not a function within pandas. It's a method of the data frame object. And you'll just have to get used to this. Like some fall within the actual object, some are stored within the pandas package. You'll get the hang of it. In this case, it's part of the object. We then pass in what column we want to do the grouping on, in this case, duration group. And then check it out. I didn't specify a numerical column that I want to do the operation on. And that's okay. All I'm saying here is take the resultant data frame, all the numerical columns, and count, or actually all the columns and count. Because count will work on both numerical and non-numerical data. Okay, check it out. So what this is telling us is that within the column IMDb title ID, we have 72,000 titles falling in this range, 13,000 titles falling in this range. Note that approximately all of these are the same, right? We have some that are different. Check out the language column. There's slightly fewer in the first bin. And this is because we have some null values in those fields. That's why the count is lower. There's some nulls. But another thing I could do to keep with the paradigm I mentioned earlier is actually select a column. So here I've actually selected the column that I want to perform the operation on, right? So I'm counting now the number of titles that fall within each group of the group by. Now let's find the mean of each of the columns for each duration group. Notice what happens to the non-numeric columns. Okay, so count. Count is something that works on both numeric and non-numeric data, right? We can always count the occurrence of things. Mean, however, doesn't work on categorical data. So when I call mean without specifying a title, Pandas auto-magically down selects the number of relevant columns to ones that I can perform the mean aggregation on. Right, so now I'm looking at duration, vote, etc., the average value for each of these duration group bins. What's something we can check for here to do a sanity check? You guessed it. The duration column should fall between the bin ranges, right? So 93 minutes is the average length of movie for movies falling between 40 and 117 minutes, 136 minutes for the bin range 117 to 194, and so forth. Cool. You can specify a group by using the names of table columns and compute other functions such as the sum, count, standard deviation, and then the describe method that I mentioned earlier. Like I said, it's one of my favorites, so let's go with that. So I'm grouping by duration group again. I'm selecting Metascore and then calling describe on that column. So it's kind of interesting. We see that on average, The shortest movies, so movies between 40 and 117 minutes, have a 54 average Metascore. I believe this is out of 100, if I'm remembering my IMDb correctly. Whereas movies that are slightly longer, up to 194 minutes, average a 63 Metascore. Notice the standard deviation is quite high, so we might not want to read too much into that, right? These are within a standard deviation of each other. So statistically, maybe not so significantly different, but interesting that the average rose. Now, before going on to these other duration columns, this is why I like the describe method so much, because we can do a lot of analysis in one fell swoop. Note how the counts fall drastically, right? So before we go reading into these really astronomical metascores for those ranges, note how we have very, very small sample size. Awesome. The simplest version of a group by looks like this. So this is a bit of a recap. And you can use almost any aggregation function you wish. We've already mentioned some of them. So the formula goes like so. We have our data frame object. We call .groupBy. We pass along the column that we want to group on. We then either select a column or perform an aggregate, or go with all columns, and then pass in an aggregation or operation method. You can even group by multiple values. For example, we can look at the Metascore grouped by the duration group and country. All right, so here I'm grouping by the duration group and then the country, and then I'm selecting the Metascore and then aggregating with the describe method. Notice how that group by operation resulted in us having a hierarchical index, right? So the first index value indicates the duration group and the second index value indicates the country. And notice how our notebook makes this really nifty highlighting for us too. All right, before we hop off for the day, last exercise. Exercise 6, group by. Use pd.cut to perform a grouping of one or more of the data frame columns. Use group by to group by that column or those columns, and then perform 3 different statistical summaries in 3 separate instances. I am going to do the shortened version of this and maybe do 1 summary. So what's a column we could group by? Well, if we're going to use pd.cut, it's got to be a numerical column. So let's check out our numerical columns. I didn't show this earlier, but Pandas has a unique or a useful function called select dtypes. I lied. Is it our data frame that has this? Yes, it is our data frame. So let's go with numerical, maybe. Number, maybe. Okay, cool. So what I've done now is I'm looking at columns that are numerical that I could then perform a binning on. We already did duration. Maybe we want to do average vote. We can do that. All right, so let's just go with that. We'll do pd.cut df average vote. We'll do 10 bin sizes, 10 bins rather, and we'll set this equal to vote vote bin. I don't know, something like this. And we can check out what vote bin looks like now. You'll notice me using underscores. There are some modules, I think in particular like stats models, that forces you to have, like it won't work well with spaces and headers. So sometimes it's, depending on what you're going to end up doing, it's good to not have spaces in your header field. Nice, so I've created these bins. That's great. So let's use group by now, df.groupby. We'll pass along vote bin. And then let's pass country. How about that? And look at, I don't know. Right, so we're looking at just the number of countries that fall within each score range. So there's 36 countries that are producing movies at 9.01 between 9.01 and 9.9 as the highest vote. Right? So maybe we call that 90% and higher. So 36 movies or 36 countries producing A-list movies. And the highest frequency country in that range is India, with 10 movies occurring in that range. Actually, and then runner-up, 8.12 to 9.01, again, is India. Cool. So Bollywood making a lot of super popular movies out there. Actually, I've never done this analysis before. Literally just first things that came to mind. So I learned something today. And that's it. So there is an associated lab with this session. Again, here's the main website. It will tell us what we're working on. So today was session 5 pandas. There's a lab associated with this session. No project notebook for this session, but up to this point, you should have completed project part 2 for the OOP and tic-tac-toe. Let's just quickly look at the lab. Here it is. And we'll have 10 different pandas exercises for today's session. Thank you for visiting and hopping on. Good luck.